Today I'm going to talk about LeetCode question number 76, minimum window substring. So given two strings s and t of lengths m and n respectively, return the minimum window substring of s such that every character in t, including duplicates, is included in the window. If there's no such substring, to return empty string. Such as the answer is unique. A substring is a contiguous sequence of characters within the string. Okay, so if we have this first example here, we want a substring of s that contains A, B, and C. Okay, so let me write this out. Okay, so we want A, B, and C in this substring. So possible answer could have been A, B, C in this range here. But obviously we have a better range of B here, here, here. Okay, we want the smallest range there. How to do this? One way to do this brute force is starting from our one of the letters within T here. We could start from A and iterate through the rest of the string as such that we find the rest of the letters in T, like B and C. We could keep track of those in a dictionary. So for in T, our dictionary would look like this: A1 and B1, C1. Okay, and so we iterate through the string until this these requirements are met. So if we have our string S here, so we have A1, okay, we go in, this is not in T, so we keep going, not in T, so we keep going, B, and once we added A, we have to check, is S equals to T? No. Then we continue, and once we now add B, we need to check, is S now equal to T? Nope. So, and not only equal, we could have it like here too. So here the value of S would be 2. We don't need to check if it's equal. We need to check if it's greater than or equal. So for S, B greater than or equal to B of 2 greater than or equal to B of 1. Okay. But anyway, and here's C, and then we need to check for each value in the dictionary, is value of A in dictionary S greater than or equal to 1, value of B greater than or equal to 1, C greater than or equal to 1, and if all these conditions are met, then we have a possible substring here. And then we need to do this, continue doing this, so to find the smallest possible substring. So we looked at A already and determined like this is a possible substring. So now we can iterate through the string and start looking at D. We can start at D, but I think it'd be better if we start at a letter that's actually in T. We start at, oh no, we can start here. Okay, and same thing as before, we want to check if all the dictionary values in S are greater than or equal to the dictionary values of T. So yeah, that's some repeated work there. So like here, B would be 1, and E we ignore, C would be 1, then we have to check are each of these values greater than or equal to the values in T, and so on. And that's a lot of repeated work, checking for each dictionary entry if it's greater than or equal to. Okay, look here, and here, if we go on with this, B, E, C, O, D, A, B, this would turn into 2, and here, and this would also be a possible substring where B is repeated twice, but that's okay. We just want all the characters in T to be in the substring here. But yeah, that is a lot of repeated work. So better yet, better than doing check-in if each entry in the T dictionary is less than or equal to that of the S dictionary, or whatever's in the S dictionary is greater than or equal to whatever's in the T dictionary. We can keep track of what we two variables, what we want and what we need. So what we want or what we have and what we need. So what we need is 3. We need 3 characters from T. 1, 2, 3. And what we have, we can calculate going through this string, going through this string here. And this is a good example of a sliding window where we just erase this. So yeah, this is a good example of a sliding window where, you know, we have A, we add that to our S dictionary, I'll put this up here. Okay, so we have our T dictionary and our S dictionary. So we found A, so we have A to be 1 here. Okay, and since these are equal, what we have is 1. Okay, and then we go to D, we ignore, then go to O, ignore. It's part of the substring anyway, but we need to add this to the dictionary here. We have B now, which is part of T, so now we have B 1, and what we have now is 2 since these are equal. This B and this B are equal. Okay, and we go on, and we finally find C, and that is 1, and since they're equal, and we increment have, and since need and have are the same, here's our first substring. Okay. And what we want to do now, since we have this window from here to here, is we can now decrement the window such that have is less than needs again. Okay. So why do we want have to be less than need? Well, what if we have like an A here, and we have 2? So have is not 4 because we wanted only one occurrence of A, and which we had so already. So that was fine. We could increment A to like 1,000,000, but all we needed was 1 A, so our have would only be incremented by 1. But anyway, so let's say we have this string here, and we want to shorten our sliding window. So how we shorten it is have less than need, less than need. So we remove that from the window, and A is now 1 again, but have is still 3, okay? And this is still a possible solution, okay? We have this guy here. But how do we start expanding the window? As I said, have has to be less than 3. So now we remove this from the window, and now our window is starting from here all the way to here. Now we need to look for an A again, so now this is when we start expanding our window from the right. So we go looking for an A, and here it is. I forgot to decrement the A before, but now it's 1. And here's another possible solution here. Great. So now let's start decreasing our window size until have is less than need. So decrement, 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 and now that we exclude B is now 0. Now we need to, oh sorry, B is now 1 still because I forgot to count this B. Okay, B is still 1, condition is still okay. So decrement, decrement, decrement. Okay, and now our window is here, and we just passed C, so C is now 0. So now we have to keep incrementing until we find another C, which we do here. And next one. Okay, now we decrement. The condition is have is less than need. Decrement, decrement. And while we decrement, we always check if while have is equal to need, then we store that shortest substring in our result. Okay, so if we were like here, while we decrement, our substring is of length 1, 2, 3, 4, 5, 6, 7, then decrement 6, 5, 4, okay? And we have this guy here. So now B is now 0, and what we have is now 2, but we can't expand anymore. So we're done there, and now that we had a substring of length 4, or substring of length 4, and now our answer would be B, A, and C, because that is our shortest substring. So B, A, and C. Okay. Now to code this up, we want our results. So I'll have my result initially positions -1, no result yet, and result length is equal to float infinity. That's a good value to have because we want the minimum result length, so we can easily do that min function of result len substring len easily. Okay, and then what we need are 2 dictionaries. So dictionary T is equal to counter T, okay, and then our dictionary for S equal to empty, and we want our window, starting over window, equal to 0 at first, and what we need is the length of dictionary T. Okay, what we need is the length of dictionary T, so it's basically the number of unique characters, and we need the number of unique characters because later then we can compare the equality, just to check if in dict S we have the same number of characters in dict T. Okay, and if they're the same, then what we need is basically +1. So if we have like T is equal to AA, then what we need is 1. Okay, we need 1 where lowercase a is equal to 2. Okay. What else do we need? I think we should be good for now. I also want to take care of 2 cases. So if length of S is less than the length of t. That means we can never find t in S. So we'll return empty string. And also, or t is equal to blank, and return blank. Okay, and this would be O of n time complexity. So for window and character in array S, if character not in dict T, then continue. We don't really care about it. We don't really care about counting it, I mean, in dictionary S. It'll still be within our range though, of window start and window end. Okay. So now what we want to do is for that character, if character in dictionary of S, or actually not in dictionary of S, dictionary of S, character is equal to 1, else if it doesn't already exist in S, that equals that plus 1. Okay. And now once we do this, if dictionary of S for char is equal to dictionary T for char, if they're the same number in both dictionary S and dictionary T, then I forgot to say I want T 0, or sorry, have, then have plus equals 1. Okay. And now what we do is decrement or shorten our window from the left. So while have equals need, what we want is if first we want to check is this substring between window start and window end less than our result length. So if window end minus window start plus 1 less than result length, then what we want to do is set result to be window start window end plus 1. I do plus 1 because in the end, at the very end, when I want to get the substring of S, I would have to do plus 1 anyway, because in Python when you truncate the latter portion of the truncation is non-inclusive. So result is equal to that. Result 1 is equal to that, to the shorter window length. Okay. And then what we want to do here is current character is equal to S at window begin. Now we're starting to shorten our window from the left. Okay. And now we want to decrement that from in our dictionary, because since we moved the window, this is no longer part of our substring. And now if this guy here is less than its counterpart in dictionary T, then have minus equals 1. Okay, and finally we want to increment our window. Okay, so that's how we shorten and lengthen our sliding window from the left and the right. It's on these conditions. Okay. So finally, so if result n is still infinity, we haven't found a solution, and return, then no solution exists, and return a blank, or else we're gonna return s result 0 to the range s result, to the range is 1. Okay. And I don't do +1 at the end because I took care of that here. Right? As I said, this is non-inclusive, but I took care of that here. Okay. And now let's try it out. Okay, looks good. Let's see the rest of the examples here. Oh, interesting. Let me see what's going on here. So this means that D is not in. Oh. Okay. Well, while we're decreasing our window, we could come across characters that we chose to skip and not like here, and not add to a dictionary S. Okay. Alright, looks good there. Alright, thanks for watching.